This lesson is on integrating with the U substitution technique, and so we're going to start with what is du? We have lots of ways to represent our derivative notation. So this is probably our favorite, f prime of x or y prime, and then this one is the derivative of the function y with respect to x, and that's Leibniz notation. In finding the antiderivatives with the U substitution method, we're going to use this form of the derivative of u with respect to x, so du over dx. So what is the derivative of u with respect to x? That's what we say, and so what we're going to see is that if we let u equal 5x plus 10, then the derivative of u with respect to x is equal to the derivative of 5x is 5 and the derivative of 10 is nothing. Now, in order to perform U substitution, you're going to perform a little algebra. So what's going to happen is if du over dx, you can kind of treat that like a division. If du over dx equals 5, then it's a ratio that we can actually multiply both sides by dx, and those dx's cancel, and you're left with du equals 5 dx. So the derivative of u with respect to x is a ratio that we can manipulate it as if that were division. So we're going to multiply both sides by dx. Okay, so let's practice that. So it says for each of the following find du. So if we let u equal 6x cubed minus 2x, then the derivative of u with respect to x, du over dx, is 18x squared minus 2. And then if we multiply both sides by dx, we get du equals parentheses 18x squared minus 2 dx. If we let u equal x to the 1/4, then the derivative of u with respect to x is 1/4 x to the negative 3/4, and then if we multiply both sides by dx, we get du equals 1/4 x to the negative 3/4 dx. Alright, so why do we need to know this? So when we use the technique of U substitution, we're going to be finding du and dx in order to find the antiderivative. And we will need to use simple algebra techniques to change the form of simple equations. So when should you use U substitution? Well, if you've got a variable expression raised to a power, so if you have two terms raised to an exponent, you can't distribute the exponent over addition or subtraction. So we're going to let u equal this, everything in this parentheses here. If you have a variable expression and it's the exponent of e, so like if you had e to the 8x squared minus 6x, you would want to use U substitution and let u equal that power. If you had the natural log of 2x plus 5, something other than just x, you would let u equal that. If you had a variable expression in the denominator, so if you had like 4x is equal to 3x minus 6, 4x divided by 3x minus 6 rather, then there's no quotient rule, so you would want to rewrite that as 4x times 3x minus 6 to the negative 1, and then you would let u equal that. So if you have a denominator, it's going to become the u when you move it up. So basically you want to think of u as the big ticket item. The most complicated looking thing that's inside of parentheses is what u will be. Okay, so I wrote a bunch of steps here, so we're going to go through these steps for U substitution. So this first one, the integral of 3x squared times 10 plus 2x cubed, all that to the 5th power dx. The first thing you want to do is not do wrong algebra. So you can't distribute 3x squared inside to both of these terms because this is to the 5th power, and PEMDAS says you have to do the exponents first, so you can't multiply. And you can't distribute this exponent over addition, because this just means this 10 plus 2x cubed times itself 5 times. It doesn't work to distribute the 5. So basically, whenever you have a binomial or a trinomial in parentheses to a power, that's a U substitution problem. And so what you're going to do is you're going to let U equal what's inside the parentheses. This is our big ticket item. So I'm going to let U equal 10 plus 2x cubed. I'll write it down here. U equals 10 plus 2x cubed. And then what we're going to do is we're going to find the derivative, but we're going to write it Leibniz notation. So the derivative of U with respect to x is du over dx, and the derivative of 10 is nothing, and the derivative of 2x cubed is 6x squared. And then solving for du just means we're going to multiply both sides by dx, and so we're going to get du equals 6x squared dx. Okay, and so after a while you can skip from u equals 10 plus 2x squared to du equals the derivative 6x squared dx. So it'll be something that we'll skip this middle step here. Okay, so after you get u and du, you check off the pieces of du that you have. So what that means, you've got this 10 plus 2x cubed is u, so this part is u to the 5th. And then you're always going to be looking at this first piece and this end piece together. Okay, and you look and see what you have. You have 3x squared dx is what you want, but you have 6x squared dx. So the good news is the dx is there, and also even better news, this is always going to happen, this x squared is there. So the only difference between 3x squared dx and 6x squared is the multiple of 2. And we're just going to use common algebra. So you're going to divide both sides by 2 to get that 6 to become a 3. I don't like to divide by 2, I like to multiply by the reciprocal. So I'm going to multiply both sides by 1/2. That's legal. And that gives you 1/2 du equals 1/2 times 6 is 3x squared dx. So now I am ready, and I put a box around this. I'm ready to finish crossing out everything. So 3x squared dx is right here. 3x squared dx is equal to 1/2 du. So I'm going to cross that out and put 1/2 du in its place. And see, this is my objective. My objective with U substitution is to get a new integral that I can easily take the antiderivative of. All of that in the work in the box was to create a new integral that is easy to take the derivative of. So I like to have an integral at the beginning, a box, and then another integral. That reminds me, I don't just leave it up there, it reminds me what my whole point was, is to get a nice integral. So now I have the rule, the power rule for basic integration. The antiderivative 1/2 u to the 5th is 1/2, constant comes down, times the antiderivative of u to the 5th. You add 1 to 5, that's u to the 6th, and then you divide by 6. I like to multiply by 1/6. Dividing by 6 is the same as multiplying by 1/6. All right, and then the very last step, sometimes people do this too early. The last step is to just take that u and say, oh, that was 10 plus 2x cubed, so you just put it back. So this would be 1/12 10 plus 2x cubed, that's u to the 6th plus c, and that's my derivative. Okay, so the rest of this says you should only be missing a numerical factor, if anything. So that's what I was talking about here. It was 6x squared dx, but we wanted 3x squared dx. Okay, so what you want to do is you multiplied both sides by 1/2 to turn that 6 into a 3, but do it legally. And then we have a new integram. Then we integrate in terms of u, and then we change back to the variable x, where we said u was 10 plus 2x cubed. All right, so let's keep practicing. Also, this is another way to do it. I have u to the 6th divided by 6. That's fine. I put the 1/6 instead of dividing by 6. So either way is fine. All right, here's another one. All right, so first thing we have to do is rewrite this. You cannot have a radical, and you also cannot have a denominator. So this whole thing is under a radical. So I'm going to put the understood 1 there and an index of 2 there, and that would be to the 1/2 power, but it's also in the denominator, so I'm going to move it up to the numerator, and that's going to become a negative 1/2 power. Okay, and again, you want to have this integral, this s, and the dx. The dx is important with U substitution because you use it. It's important. Okay, so this is my rewrite. Now I'm going to let u equal the big ticket item. This is in parentheses, I know that, but this is in parentheses to a power. So I'm going to let the x squared plus 4x be equal to u. And then I'm going to take the derivative of u, and the notation for derivative of u would be du over dx. So du equals 2x plus 4, and I know I'm going to multiply by dx every time, so I just wrote down du equals 2x plus 4 dx. Put parentheses around the 2x plus 4. So then you stop and you just kind of write down what you have. So once you got u and du, let me write this down. All right. You want to cross out what you have and you look at what you need. So I have my u to the negative 1/2. So I cross that out. And then I look at x plus 2 dx. X plus 2 dx is what I want, but what I have is 2x plus 4 dx. But the good news is every variable is the same, it's just a different multiple. So you can see that x plus 2 is what I want, 2x plus 4 is what I have. I can multiply both sides by 1/2 and get 1/2 du is equal to 1/2 times 2x is x, and 1/2 times 4 is 2, and it gets me to what I need, x plus 2 dx. So now I'm going to look up here and I say here's my x plus 2 dx. Down here's my x plus 2 dx, and it equals 1/2 du. So I'm going to cross that x plus 2 dx and put 1/2 du in its place. And I like to put a box around all this work here because it reminds me I started out with a complicated integral, but now I just have the integral of 1/2 u to the negative 1/2 du. So the whole goal of U substitution is to get an integral with u and du so I can take the antiderivative. So that's my next step, is I'm going to take the antiderivative. So 1/2 comes down, and then I like to skip a little space here, and then I'm going to add 1 to negative 1/2. So negative 1/2 plus 2 over 2 is 1/2, and then I'm going to divide by 1/2, but dividing by 1/2 is the same as multiplying by 2. And I just took the antiderivative of u. And the very last step, after I took, the whole reason I'm using u is to take an easy antiderivative. Now once after I take the antiderivative, then I can put u, what u is, back in it. U is x squared plus 4x. So this 1/2 times 2 is 1. U is x squared plus 4x to the 1/2 plus c. So that is my antiderivative. Okay, we'll keep going. All right. Number 3. Here's number 3. Okay. So the integral of 1 minus x squared divided by a binomial x cubed minus 3x. So you can't divide out the monomial. You're going to have to rewrite this as 1 minus x squared times x cubed minus 3x to the negative 1 power. That's how I bring it up. Now this is my preferred method. Some videos you might watch where you just keep it down there at the bottom, but I don't like to do that. I like to move it up to the top. Okay, the next step is to decide what u is. So u is going to be the whatever is in the parentheses that has a power. So u is x cubed minus 3x. Okay, then I'm going to take the derivative of u, which is 3x squared minus 3, and it was du over dx, but I'm going to multiply both sides by dx. So I get du equals 3x squared minus 3 dx. Okay, after you get u and du, so I get x cubed minus 3x, and du is 3x squared minus 3 dx. Okay, after I get those two, I stop, and I'm just going to, my job is to get that integral much more simple. So x cubed minus 3x to the negative 1 is u to the negative 1. And then I say, okay, I need 1 minus x squared dx, but all I have is 3x squared minus 3 dx. So you have to look and see that this is really close to the same thing. They both have an x squared. So what times 3x squared would give you negative 1x squared? And what times negative 3 would give you positive 1? And you can see it's turned around, so these are opposite, so you're going to need to multiply by a negative, and you're going to need to divide by 3. So if you multiply both sides by negative 1/3, that's legal. Whatever you do on one side, do the other. You get negative 1/3 du is equal to negative 1/3 times 3 is negative x squared, and negative 1/3 times negative 3 is positive 1. And then you have your dx. And so you have the same thing. 1 minus x squared and negative x squared plus 1, that's the same thing. Okay, so now I'm ready to cross this out. So 1 minus x squared dx is equal to negative 1/3 du. And we still haven't taken the integral. So remember, all of this was to get this new integral, the integral of negative 1/3 u to the negative 1 du. The whole reason I did this is so now I can take this antiderivative without all of this stuff. So the antiderivative of negative 1/3 u to the negative 1 is negative 1/3, constant comes down, and then remember the integral of u to the negative 1, or 1 over u, is natural log of u, absolute value of u. So negative 1/3 times natural log of absolute value of u plus c is the antiderivative of this integral that has u in it. Okay, so we made an easy integral. We took the integral. Now the very last step is our u was x cubed minus 3x, so you put that back. So negative 1/3 times the natural log of absolute value of x cubed minus 3x, close absolute value, plus c. Okay, let's keep going. Alright, here is another one. And again, you can pause the video if you need to go back and review, or if I go too fast, you might want to try this one on your own. So what I'm going to do is rewrite this because I have a radical and I have a denominator. So this is going to be 3 minus 8x divided by 8x squared minus 6x plus 5 to the 1/2 power, but I don't want to divide, so I'm going to move that up. That's why it becomes negative 1/2. So 8x squared minus 6x plus 5 to the negative 1/2 dx. Okay, so again, we want u to be the big ticket item. We want u to be the stuff that's in the parentheses that has the power to it. So I'm going to let u equal 8x squared minus 6x plus 5. And then I'm going to take the derivative of u with respect to x, but I know that my dx is going to come over to this side. So this is The derivative of 8x squared is 16x. The derivative of minus 6x is minus 6. Put it around parentheses, and you have your dx. Okay, then you have to stop and look at what you have and what you need. So I have u to the negative 1/2, and I need 3 minus 8x dx. I need that, but I have positive 16x minus 6 dx. But again, at least you have the same x. And negative 8, this 16 needs to become a negative 8, and this negative 6 needs to become a 3. So what times 16 would give you negative 8? So if you divided this by negative 2, okay, so I'm going to multiply both, dividing by negative 2 is the same as multiplying by negative 1/2. So I'm going to multiply both sides by negative 1/2, and that is going to give me negative 1/2 du equals negative 8x plus 3 dx. So now I have 3 minus 8x is the same thing as negative 8x plus 3 dx. So now I'm going to cross this out. So you're not done until everything here is gone. So that 3 minus 8x dx is equal to negative 1/2 du. And I'm visual, so I like to put a box around this, and then my goal is to get a new integral, and so I'm just going to write down the integral of negative 1/2 u to the negative 1/2 du. So I went from a really crazy looking interval to just this one that has a constant and a power. So I'm going to take the integral of this, so that would be negative 1/2, and then you add 2 over 2 to negative 1/2, and you get positive 1/2. Dividing by 1/2 is the same as multiplying by the reciprocal of 2, which is 2, plus c. And now all the hard part is over. It's just now you got to replace the u with what you let u equal. So I'm going to go ahead and simplify that. Negative 1/2 times 2 is negative 1, and then u was 8x squared minus 6x plus 5 to the 1/2 power, and then plus c. So this is the antiderivative. So if you wanted to check your work, you could take the derivative of this, and you should come up with that. So we could use the chain rule just to check. So the chain rule would be negative 1 times 1/2 is negative 1/2 times the inside without negative 1/2 times the inside, don't change it, to the negative 1/2 times the derivative of the inside, which would be 16x minus 6. And then if you multiply this times that, distribute, you get negative 8x plus 3 times this, which is a negative 1/2. Alright, and that gives you what you started with. Alright, let's see. Now the question is going to come up soon. Not yet. So let's see what happens when you have an EX1. I have a cat trying to get in. Alright, so what happens if you have an e to the x? Well, nothing different. So the main thing is that you have to notice you're dividing by 2 terms. So you can't simplify this. So you're going to have to use U substitution. Anytime your denominator is 2 or more terms, you can't divide it out. You're stuck with it. So the first thing I'm going to do is rewrite this as e to the x times 1 plus 2 e to the x to the negative 1 power. Okay, so that's my rewrite. And then I have a binomial to a power, so I'm going to let u equal 1 plus 2 e to the x. Then I'm going to take the derivative of u, which is the derivative of 1 is 0, and the derivative of 2e to the x is 2e to the x dx. Okay, and then after you get u and du, you stop and say, okay, I have u to the negative 1, and I need to replace e to the x dx, but I have 2e to the x dx. So I'm going to divide both sides by 2 or multiply both sides by 1/2. So that becomes 1/2 du times e to the x dx. So now e to the x dx is right here. E to the x dx is equal to 1/2 du. So cross that out, 1/2 du, put it in its place. But I haven't taken the integral yet, so it's the integral of 1/2 u to the negative 1 du. Okay, so now I'm going to take that antiderivative. So the constant comes down 1/2. And the antiderivative of u to the negative 1, remember, is natural log of absolute value of u. Okay, so then the last step after you take the antiderivative, the last step is to put what u was back in, and u was 1 plus 2 e to the x. Absolute value bars around that, plus c. Okay, let's keep going here. All right, here's an E one. So this is a new type. It is 3x cubed e to the 6x to the 4th. So if your power of an E function is other than x, then you're going to have to use U substitution. So you want to let u equal the power of E. Okay, so u is 6x to the 4th. Then you're going to do the same thing. You're going to take the derivative of u, which is 24x cubed dx, and then you're going to stop, and you are going to replace your what you can. So e to the 6x to the 4th is going to become e to the u. And then you stop and say, I need a 3x cubed dx, but I have 24 x cubed dx. So if I divide 24 by 8, I'll get 3. So I'm going to multiply both sides by 1/8. So that gives me 1/8 du is equal to 3x cubed dx. Okay, so I got to cross this stuff out. So 3x cubed dx is right here, and it equals 1/8 du. So 1/8 du is going to go in place of 3x dx. So the integral of 1/8 e to the u du is what I need to take the antiderivative of. Much easier. The constant comes down, 1/8, and the antiderivative of e to the u is e to the u plus c. So this is almost an afterthought. This last step, sometimes people do it too early, is 1/8 e to the u, which was 6x to the 4th. So that's always your last step. So a couple of mistakes people make with this is you don't want u does not ever equal e to the, no, u is only going to equal the power, okay? Think about it, because e to the u is really easy to take the antiderivative of. So it's okay to leave the e in there. You just want to replace the power with u. Okay, so that's an E function U substitution problem. Let's see what else we have. Here's another one, but it's not the same type of E function. This is just a binomial to a power. So I'm going to let u equal 2 plus e to the x, and then the derivative of 2 is 0, and the derivative of e to the x is e to the x. But remember, du with respect to x, this is dx. Sometimes people forget to write that down, and then they get a little lost on what they're doing. So remember what we're doing. After we have u and du, we stop and say, okay, I have u to the 1/2, and I need e to the x dx. And here it is. E to the x dx equals du. Something else happens to people. Sometimes there's a number missing and they get a little confused. So if you get a little confused, you need a coefficient, just put the 1 there. So e to the x dx is equal to 1 du. And that's what we want to take the antiderivative of. We want to take the antiderivative of 1 u to the 1/2 du. Okay, so the antiderivative of 1 u to the 1/2, I just put that 1 there because that tends to kind of make people get stuck. But you don't really need it here. The antiderivative of u to the 1/2 is u to the 3 halves divided by 3 halves, which is the same as multiplying by 2/3. So that's the antiderivative. And then the last step is you didn't start with u. You said u was 2 plus e to the x. So parentheses 2 plus e to the 2x to the 3 halves. So that's that. Okay, remember, pause the video if you need to. All right. Let's do, I know you're probably tired of listening, but I'm going to go ahead and skip. I'm going to come back to this one, but I want to go to this one before you get too bored, because there's something else that might happen, and this is what I want to talk to you about right here, this one right here. It looks innocent. All right, so I've got 8 minus p squared to a power, so that's what I'm going to let u equal. Okay, and then I'm going to take the derivative of u, and the derivative of a to 0, the derivative of negative p squared is negative 2p dp. And so another thing that happened is the variable changed. So this derivative of u with respect to p is du over dp, and multiply both sides by dp, and you get negative 2p dp. Okay. Again, what you do is you stop and say, okay, what do I have and what do I need? So I have 8 minus p squared to the 7th is going to become u to the 7th, and what I need is 5p dp. And this is a little harder, because I need 5p dp, but I have negative 2p dp. The good news is they both have a p, so the only thing that's different is 5 and negative 2, but up until this one, it's been like 6 and negative 2, and you're like, oh, I multiply by 3. Or it's been like 5 and 10, and you would say, oh, I divide by 2, but 5 and 2 don't go into each other very well. So that tends to bother people sometimes. But my little thing that I say is, this is what you need, right? And this is what you have. So what you're going to do, if you just multiply both sides of the equation by what you need, which is 5, over what you have currently, watch what happens. If I multiply both sides by what I need is 5 over negative 2 and multiply both sides by that, you have to understand fractions. So see, what happens is this negative 2 in the denominator is just going to cancel with this negative 2 that's in the numerator. And you will end up with negative 5 halves du is equal to 5p dp. So you just, if you have a fraction that's kind of hard to see, you're going to multiply by what you need over what you have. Both sides by what you need over what you have, and then because what you have will cancel out with what you have, and you're left with what you need. Okay, so you have 5p dp, you have 5p dp, so you're going to replace 5p dp with what's on the left here, negative 5 halves du, and that is your new integral. So the integral of negative 5 halves u to the 7 du is my new integral. Right, now I'm going to take the antiderivative. The constant comes down, so negative 5 halves, and I have a fraction here, so I'm going to skip a little space here. Add 1, that's u to the 8th. Instead of dividing by 8, I like to multiply by the reciprocal. So I multiply by 1/8 plus c, and then I can combine this. That's negative 5 over 16, because you're just multiplying fractions straight across, and then replace u with 8 minus p squared, and it's to the 8th power, plus c. Okay, so I just wanted to go over that one. I was getting anxious about that because sometimes your multiples won't be as easy to deal with. Sometimes you'll have to multiply by a weird fraction, but it's really not that weird. You multiply by what you need over what you already have. Okay, so the objective is to replace all of this with something easy. So I need a 5p so I can replace it. All right, let's see. So I think the other ones kind of go back to anything can happen here. So, pause the video and try it. We're at 34 minutes. All right, I'm going to rewrite this as 1 minus e to the negative x over x plus e to the negative x, all of that to the negative 1 power. Okay. Then I'm going to let u equal the parentheses that has the power after it, so that I'm going to let u equal x plus e to the negative x. Okay, then I'm going to take the derivative and I'm going to write du and then equals, and then the derivative of x is 1, and this is the chain rule. This is e to the negative 1x, so that the way you do the chain rule for e functions, this derivative is e to the negative 1x times the derivative of the power, which is negative 1. So I'm going to write my constant in the front. So the derivative of negative 1x is negative 1, and then the e to the negative x. So that's the chain rule for e functions. And then don't forget to put dx down there. So you have du equals 1 minus e to the negative x dx. Once you have u and du, you stop and you check off what you have and you look at what you need. So I have a u to the negative 1, and I need 1 minus e to the negative x, and I have 1 minus e to the negative x dx. Okay, so if you need to, put a 1 in front of that du. So 1 du equals 1 minus e to the negative x dx. So I can cross out the 1 minus e to the negative x dx and put 1 du in its place, and I have my new integral, which is 1 u to the negative 1 du. That's my new integral. The 1 isn't really needed, so you just remember, what is the antiderivative of u to the negative 1? It's natural log of u, absolute value of u plus c. So we took the antiderivative. The very last step is to put the u back, and that's natural log of absolute value of x plus e to the negative x plus c. So that one looked really hard, but there wasn't much multiplying needed in that du equation. All right, let's see. All right, here's one you can try. Just pause the video, try it, turn it back on, check to see how you did. Okay, so I need to rewrite. So this is going to be 3q cubed times 1 plus 9q to the 4th to the negative 1 dq. I'm going to let u equal 1 plus 9q to the 4th, because it's what's inside a parentheses to a power. I'm going to take the derivative, and that's derivative of 1 is 0, and the derivative of 9q4 is q to the 4th is 36q cubed. Don't forget to write the dq. You stop and you say, okay, I have a u to the negative 1. I need 3q cubed dq. I have 36q cubed dq. So if I divide 36 by 3, divide 36 by 12, I will get 3. So dividing by 12 is the same thing as multiplying by 1/12, so that's what I'm going to do. So I have 1/12 du equals 1/12 times 36 is 3q cubed dq. So now I can say, all right, I needed 3q cubed dq. I have it, and that should be a q. I have it. 3q cubed dq is equal to 1/12 du. So I'm going to cross out 3q cubed dq and rewrite 1/12 du with the integral sign, because I haven't taken the integral yet. My job is to get a nice easy integral with a constant 1/12 u to the negative 1 du. So how do you take the antiderivative of that? Well, the constant comes down, 1/12 comes down. The antiderivative of u to the negative 1 is natural log of absolute value of u plus c. Okay, so the hard work is done. The very last step is replace u with what you let u equal, which was 1 plus 9q to the 4th. All right. Here we go. what else we got. All right, try this one. Turn back the video when you're done. Okay, got to rewrite this. So this is the integral of 5x squared times 10 minus x cubed to the, since all of that belongs under that radical, I need the exponent 1 over 2. Okay, I'm going to let u equal the parentheses that has the power, so 10 minus x cubed is my u. The derivative of u would be negative 3x squared and then dx. Okay, you stop and you look and you replace this 10 minus x cubed to the 1/2 and you say, well, that's u to the 1/2. Now I need to replace 5x squared dx. I need a 5. I have a negative 3. See that? I still have x squared, so that's good. And there's a dx, and that's good. So how do I get negative 3 to become 5? Okay, you have to remember the trick is you're going to multiply by what you need, 5, over what you have, negative 3. So I'm going to multiply both sides by what I need over what I have. And what happens is I get negative 5/3 du, and then 5 over negative 3 times negative 3, the negative 3's cancel, and you get 5x squared dx. So now I have 5x squared dx, and it equals negative 5/3 du. So my integral is negative 5/3 u to the 1/2 du. Okay, so I'm going to take the antiderivative of that. The constant negative 5/3 is going to come down. I like to skip a space because I know I'm going to be working with a fraction. I'm going to add 1 to 1/2, so 2 over 2 plus 1/2 is 3 over 2, and dividing by 3/2 is the same as multiplying by 2/3. There it is. If you want to multiply those two fractions together, you can. That would give you negative 10 over 9. Then you would replace u with 10 minus x cubed, and it's to the 3/2 power plus c. Okay, let's see what else we have. I think we might be done. All right. These are in the PowerPoint, and I haven't checked to see if those links work. One's a Khan Academy, one's a YouTube. If that helps you, you can watch it. But I would really try to learn my way, because you're going to see the way I do my keys that way. But go ahead and do the lab manual U substitution and check the key, and good luck.